Yeah, welcome everyone to my talk, and thank you for the opportunity to give it here. It is going to be about testing Yocto projects with the Yocto features Testimage and Ptest. So first, I would like to introduce myself. I come from Belgium, specifically Brussels. I moved to Munich for my studies. I studied electrical engineering at the Technical University of Munich. I specialized on embedded systems and security. I finished my master's degree last year. I had several working student positions along my studies, but the last one I had was then at Siemens, where I continued as a full-time employee after my studies. Now I am working as embedded Linux consultant. This means in my case that my colleagues and we consult other business units on how to use Linux in Siemens products. I gave internal and external talks, for example, exactly on this topic, as Josef just mentioned, at the Open Source Summit this year. I also contribute to some open source projects and inner source projects. The ones I'm mentioning here are all open source. For example, Xenomai, which is a real-time framework that integrates with a Linux kernel to provide hard real-time computing support. It's an alternative to PreemptRT. I also use, and from time to time, I give trainings on ISA and CAST. ISA is a build system for Debian-based images. And you all probably know CAST. It really helps you to set up your Yocto projects or any Bitbake-based projects. For those of you who didn't use it yet, I can really recommend having a look. I also contributed to the Yocto OpenEmbedded project this year. How did that happen? So this year I was working on a Yocto-based project at Siemens for the first time. And during this project, I added some new functionalities to the OpenEmbedded project, which I then contributed upstream. And I will talk more about my contribution later on. So let's start with the topic of today, testing Yocto projects. So first we should think about, why do we even need testing? I mean, if we don't have any tests in our project, then nothing can fail, right? No, not really. So what about all the functionalities we have in our image, all the specialties we added, the packages we installed, maybe we even created some custom packages. And of course, we want to make sure that everything is working as intended. That's where project testing becomes important. Second point, testing shouldn't be done in production, but of course, as early as possible in a project. Try to integrate testing as one of the first points in your project development to make sure that everything is working as expected. So let's have a look at the agenda for today. I will present to you two Yocto frameworks, Testimage and Ptest. So Testimage is about image tests, which are basically system tests. And then we have Ptest, which is about package tests. So I will give you a small tutorial on how to set them up and use them. Then I will present to you my learnings I had when using the testing functionalities. And after that, I will talk about the contribution I brought upstream. So let's start with Testimage. Who of you has used Testimage before? Maybe you can send an emoji. Right now, I cannot see the chat, but maybe you can, so we can get an idea how many people used it. I hope some people send some emojis. So yeah, let's start. So Testimage is about testing the functionalities in your image. What can you do? I will give some examples. So for example, you can check the network settings. So make sure that the firewall rules are correct in your image. You can check file permissions. So make sure that only the allowed users can read and write your files. You can see if your services are running or verify that all your packages are really installed. So these are just a few examples you can what you can do with Testimage. Here I also placed some links to the wiki and the dev manual, which you can check out. So let's talk about the key features. What you obtain from the test image task is a log, which has this output. So this format results, then all your tests listed, the status and the duration. So the status can be passed, failed, or skipped. Skipped means that probably there were some missing dependencies and your test couldn't be run. You will also get some other files. They are all located in the build temp log Open Embedded Quality Assurance directory. So you will get the log I just mentioned. If you use QEMU as target, you will also receive a QEMU boot log. And then you will also get a test results JSON, which contains the same, more or less the same info as the log, but in JSON format. So test image, there are the available packages. So the Yocto OpenEmbedded projects come along with a multitude of packages you can directly use. They are located in the meta-lib Open Embedded Quality Assurance one-time cases directory. But of course, you can also create your own test image tests, which you would then add into your project under your layer under the same path, so they can be found. Let's have a look at an example. Here I copied the most relevant parts of the Python test image test from the OE core project. First, we need to import the OE runtime test case class as our test is based on that class. We can use the OE test depends to name dependencies to other test image tests. Here, for example, we want to make sure to run the SSH test successfully first before running this Python test. And then we can also name dependencies to certain packages, which we need to execute the test. After that follows our test definition. How can we enable test image in our image? We need to append the image classes variable with test image. We also have to specify which tests we actually want to run. Here for demonstration purposes, I wrote 3 really simple tests. I called them fail, skip, and success. I placed them in my layer under the correct path, and they don't do anything special. They don't check for firewall rules or whatever. They just do exactly what their name says. And this is for demo purposes, so you can have a look how the log would look like. So we added them to our test suites variable. What do we have to do next? We need to specify our test target. So we can use QEMU. Then, depending on the used architecture, we may need to adjust some QEMU root variables. We can also use hardware. Then we would use the simple remote target, and then we would have to specify the IP address of the target. What we then need to do is build this image, install it on our target, connect via SSH, and run the test image task. How can we do that? We just execute bitbake-c test image and then our target image name. What will we get out of that? So for our 3 example tests, we would get a log similar to that one. So I copied some snippets from the log. We get exactly the output we expected here, passed, skipped, failed. And so we will also get some more info in the log why a test was skipped, why it failed. You can imagine that if you're running hundreds of tests, this log can be quite long and cumbersome to read. So I went exactly through those problems when I was working on the Yocto-based project, and I came up to a solution for that. And I will talk more about the solution later on. First, I will now continue with Ptest. Maybe you can share in the chat if you used Ptest before. Ptest is a convention how things are packaged in Yocto. So it is a way to package up the test suite that a package or a library already ships. So some packages come with a test suite, and the Yocto Ptest feature helps you to package that up and then run it on your device under test. What kind of tests can that be? So this depends on your installed packages. It could be library functionality tests. So if you installed Zlib and the corresponding Ptest, the Ptest would ensure that compression and decompression are working correctly. You could also have some command line tool tests if you installed E2FS-proc. And another interesting point, if you have some custom packages you created, you can, of course, add your own Ptests to that and test the functionalities of your application. Here again, I placed some links. So again, to the dev manual and so yeah, as I just said, Ptest is a convention how things are packaged. So Yocto will create sub-packages for you. Where if you have the package foo, it will create the package foo Ptest. What we get out of the Ptest run is a log similar to the test image log with so the same format. How can we actually run the Ptests? For this, we have 2 files that help us. We have the ptest-runner. This is a small C application that loops through all the installed Ptest test suites on our target and runs them in sequence. And then we have the run-ptest shell script that will actually start the tests. So this is individual to every test. So the minimum a Ptest must contain is this run-ptest shell script and the actual test. Again, the Yocto OpenEmbedded projects come with a multitude of tests you can directly use. You just have to search for the inherit Ptest statement, as this is part of every Ptest recipe. And then you will just see which packages already contain a corresponding Ptest. So let's have a look at an example again. Here I copied again the most relevant parts of the util Linux package from the OpenEmbedded-Core project. First, we need to include the run-ptest shell script, as this will start a test suite. Then we can use the inherit Ptest statement to enable the Ptest magic in our recipe. So Yocto knows that how to package up the Ptest. We can name dependencies to certain packages which we need up at build or at runtime to successfully execute the test. Then, if necessary, we can compile the Ptest, which is principally make test. And then we can install it to a specific path, the Ptest path. Next, we need to see how we can enable the Ptest in our image. We first need to build all the available Ptest packages. For this, we can just append the distro features. We can then decide whether we want to install all the Ptest packages into our image. Then we would modify the extra image features. Or we can go for the other option, install just specific Ptest packages. And we would do this with the image install variable. We also need to install the ptest-runner, as this will loop through the available tests in our image and run them in sequence. So then what we get is, so we will find all the installed Ptest files in the user lib package name Ptest directory. How can we run the Ptest? We can have a look at which Ptests are available in our image. So if we booted up QEMU with the -l argument, we can simply start all the tests, or we start a specific one by specifying the package name. We can also run our tests on our hardware. Then we would SSH to our hardware and then run the ptest-runner. We can also run Ptest as part of test image. Then we need to make sure to run the ping and the SSH test first. And we would just add those two because those need to pass successfully first. And then we would just add those two as well to the test suites variable. Let's come to my learnings and improvements. So learnings first. So on the plus side, so Ptest and test image are compiled as at the same time as we compile the binaries, so ahead of time. No surprises at runtime. They are both well integrated into the bitbake procedures. On the negative side, what we obtained so far is this really large log output, which can be a bit cumbersome to read. And to visualize the test results, we needed to do some post-processing, write our own script. but not anymore. I went exactly through those problems when I was working on the Yocto-based project at Siemens. So I actually wrote a script for the visualization and I integrated it into the Yocto OpenEmbedded project and I brought it upstream. So I will talk more about this now. So with my script, we can visualize the test results in the CI/CD pipeline. The script generates a unit test report in JUnit XML format. JUnit XML, this format was chosen because this is the format GitLab can handle, and I tested this in GitLab. You can check out my commit. How can you run it? First, as usually, you need to source the OpenEmbedded build environment, and then you can use the result tool script. This is a script available since a few years in the Yocto project, and it is used to analyze test results. You can now call it with the JUnit argument since my patch, and then you hand over the path to the test results JSON. So this was one of the files we received as output of the test image task. So as a summary, we take the test results JSON as input. We let it pass by the JUnit Python script, which is called by the result tool script. And we obtain a JUnit XML. This JUnit XML is located in the same directory as the other files we obtain from the test image run. So how can we actually use this in the GitLab CI/CD? Here I'm giving an example with QEMU and user space networking. I am using cars, so I'm the cars image, and then I am just doing a normal build. So with cars, this would be this command. This is the same as just running bitbake and then your target image name. And then a second step, you would run the test image task. You can do the same with kernel space networking. Then this would look like that. And the only things you need to do is set up the tab interface, as this is used when for the communication with QEMU. For this you need to run the QEMU helper native script and then set up the tab interface. And then you just run the normal test image task. So, okay, this was only half of the truth. For the user space and the kernel space networking, we also need to do some groundwork. You can look it up here, depending on what you choose. After that, in our after script, we can now call the result tool script with the JUnit argument and the path to the test results JSON. So GitLab just needs to know where the JUnit XML is located, and then it will do the visualization for you. So it just needs to know where the JUnit report is. So how does that now look like? For our 3 example tests, we get this output. So we can see, okay, one test failed, one was skipped, one passed. We can now click on the test one to get some more information. Here we can see the duration, and we can also click on the View Details button. And for example, for the skip test, we can see, okay, there was a missing dependency. We needed bash in the image for the Ptest, for the test image test to run successfully. Yeah, regarding Ptest, this also works with Ptest. Then we would just, as I said, make sure to run the ping and the SSH test first, and then we can run our Ptests. So now I'm coming to the end of my talk. You can contact me via email. You can also connect with me on LinkedIn. I made a QR code for that. Yeah, thank you for listening. Do you have any questions?